Reduction of an oxide by carbon by KayScience.com. One way of remembering what oxidation and reduction are is by using oil rig, where oxidation is the loss of electrons and reduction is the gain of electrons. Oxidation is also the addition of oxygen, whereas reduction is the removal of oxygen. And in this video, we're going to focus on how a metal oxide can be reduced using carbon. It's question time. Attempt these questions to check your understanding. We already know from a previous video that a displacement reaction is where a more reactive element will kick out or displace a less reactive element from its compound. So using the reactivity series, carbon is able to displace or kick out a less reactive metal from its compound. So carbon displaces less reactive metals from its compound. What happens is a metal oxide reacts with carbon using heat. Thermal energy is needed when a metal oxide is reduced by carbon. The products are a metal and carbon dioxide, as the carbon displaces the metal, forming carbon dioxide and a metal. Now it's the carbon that causes reduction. Therefore, carbon is a reducing agent. A reducing agent is a substance which causes reduction, and in this case, the reducing agent is carbon. We can see from the chemical reaction that now carbon has formed carbon dioxide. The carbon has been oxidized, and this always happens to the reducing agent. The reducing agent is always oxidized. It's question time. Attempt these questions to check your understanding. An example of a metal oxide being reduced by carbon is lead oxide reacting with carbon to form lead and carbon dioxide. Carbon is able to displace lead from lead oxide because carbon is more reactive than lead. We know this because carbon is higher than lead in the reactivity series. The balance symbol equation is PbO, S for solid, reacts with C, S for solid, reacts to form, and then we place heat above both arrows to show how heat is used in the chemical reaction. And the products are Pb, alpha liquid, because it's a hot molten liquid, and CO2, G for gas. And then we put a big 2 in front of the PbO and the Pb, so we balance the symbol equation. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets, and quizzes at KayScience.com. And don't forget to like and subscribe.